Hello student, welcome back in online lecture series. I am Dr. Keshao Mahale, working as assistant professor in the Department of Chemistry, KTHM College, Nasik. Friend, in last lecture we have discussed the 5-membered heterocycles which containing one heteroatom. In that lecture, we discussed that there are 3 5-membered heterocycles: Pyrrole, Pyrrole and thiophene. We have discussed how these heterocyclic compounds are aromatic and what are the resonance structure of this type of compound, and we have also discussed the comparative aromatic properties of this compound. Friend, in today's lecture we have to discuss the reactivity of this 5-membered heterocyclic compound, that is the reactivity of Pyrrole, Pyrrole and thiophene. If we compare the reactivity of these compounds, then we can say that Pyrrole is more reactive than Pyrrole, Pyrrole is more reactive than thiophene, and thiophene is more reactive than the benzene. Friend, there are 2 types of reaction that are given by this type of compound. The first one is the electrophilic substitution reaction and the second one is nucleophilic substitution reaction. Let us discuss first the electrophilic substitution reaction which are given by this type of the compound. Let us discuss first electrophilic substitution reaction. See, in electrophilic substitution reaction, we have taken here the general structure of the 5-membered heterocyclic compound. This X is the heterocyclic compound, where X is equal to, we can take here the NH for Pyrrole, oxygen for Pyrrole and sulfur for thiophene. So, when these heterocyclic compounds react with electrophile, then there are 2 types of the substitution. See here, the first type of substitution is on the second position. If we given the number, see, this is the first, second, third, fourth, fifth. See, there are 2 positions for the substitution. See, this is the alpha position and this is the beta position. Once again, this is alpha and this is beta. So therefore, there are 2 positions. See, these 2 are the alpha position and this is the beta position, and this electrophile can be substituted on either position alpha or either position beta. Let us first see here, if the electrophilic substitution takes place at 2 positions, that is the alpha position. See, this double bond remains as it is. This electrophile attached to the second position, that is the alpha position. We write here the alpha position and the positive charge becomes at beta position. Now, you can see that this structure can be stabilized by the resonance structure. So, this bond shift here to neutralize this positive charge, and the positive charge comes at the alpha position again, and then you can write the structure. See, this is the electrophile attached here, this is double bond now, this is double bond now, and this is the positive charge here. Now, this positive charge can be neutralized by the lone pair of this heteroatom. Lone pair of heteroatom comes here and makes here double bond, and the positive charge get neutralized and got the new structure, new resonance structure like this. See, this is the X, and here is the double bond, here is again double bond, and this is the positive charge on the heteroatom, and this is the electrophile. These are the three structures. See, this is 1, 2, and this is 3 structures, but we can see here the conjugate base. The conjugate base can take this hydrogen, this bond shift here, this bond shift here, and this bond get open and neutralize the positive charge, and finally we got here the substituted compound. See, this is the X, these are the double bond, and this is the electrophile. Substitute at the position 2, that is, we can have the we can call this is the alpha substitution. This is the alpha substitution. Friend, let us discuss now the beta substitution. So, see, this is the beta condition. When this lone pair of heteroatom get attacked here, and this bond shift on the electrophile, and the substitution will be at the beta position. See, this is the double bond, and this is the electrophile here. A positive charge comes here. See, this is the positive charge. Now, this structure can be stabilized by the resonance structure. This lone pair of heteroatom can attack to here, can make double bond here and neutralize this positive charge, and we got here the structure like this. See, this is the X, this is the double bond here, this is the real double bond, and this is the electrophile here. But now the conjugate base can take this hydrogen, this bond shift here, this double bond neutralize the positive charge which generated after donation of this lone pair, and hence we got here the final structure. See, this is the final structure, this is X, and this is the beta substitution. See, this is the beta substitution. In beta substitution, there are two resonance structure of the intermediate. See, this is the first and this is the second. You can see here in the electrophilic substitution reaction of 5-membered heterocyclic compound. So, which are these 5-membered heterocyclic compound? If this X is replaced by the NH, then it becomes Pyrrole. If we replace this X is equal to O, then it will be the Pyrrole, and if we replace this X is equal to S, then it will be the thiophene. So we can say that in Pyrrole, Pyrrole and thiophene, if electrophilic substitution reaction takes place, then electrophile substituted either at alpha position or at beta position. There are two possibilities. First, when electrophile substituted at alpha position, then we got here the three resonance structure of intermediates, and when electrophile substituted at beta position, then we got here two resonance structure of the intermediate, and we know that more the number of resonance structure of intermediate, more the stable intermediate, and the reaction will be feasible. Reaction will be the more percentage. So hence we can see here, we can say the alpha substitution is the major than beta substitution. Beta substitution is the minor than the alpha substitution. So generally there is formation of alpha substitution in this type of the compound. So when we takes place the electrophilic substitution, that is the halogenation, nitration, acylation, alkylation, formylation, this type of reaction, then at that time the alpha substitution takes place greater than the beta substitution. We have to keep in our mind one thing: the alpha substitution is the major product than the beta substitution. For example, we can write here the nitration reaction. Firstly, we can take here the Pyrrole when Pyrrole undergoes nitration reaction in presence of concentrated nitric acid HNO3 and acetic acid, then we got here the nitration at the second position, that is the alpha position. So Pyrrole give us 2 nitrofuran when it's substituted with the nitro group in the condition of concentrated nitric acid and the acetic acid. Again, you can write here when Pyrrole undergoes the acylation reaction in presence of acetic anhydride, then it gives us acylation at second position, that is 2-acyl Pyrrole is the product here. When this Pyrrole undergoes the formylation reaction, Pyrrole undergoes the formylation reaction in the Wilsmer-Hack reaction, anion dimethyl amine react with POCl3 at 0 degree Celsius, then it gives 2-pyrrole Pyrrole, that is CHO at the 2 position. In such a way, we can say that the electrophilic substitution reaction in this type of compound are given by this compound at the 2 position. Same way, we can say when we take here the thiophene, then thiophene undergoes when nitration reaction, it gives the 2 nitrothiophene. Thiophene undergoes the acylation reaction, then it gives the 2-acyl thiophene. And when thiophene undergoes the formylation reaction, then it gives the 2-formyl thiophene. So thiophene and pyrrole give us the same type of reaction, but in case of the pyrrole, there are formation of 2 products. One product is at the 2 position, substitution at 2 position, and another is the substitution at the 3rd position. So in case of pyrrole, you can write here. See, this is the pyrrole. NR pyrrole. When this NR pyrrole undergoes the nitration reaction, or we can and in presence of POCl3 at the 0 degree Celsius, then we got here the two products. The one is the 2 substituted and another is the 3 substituted. See, this is the R and this is the CHO. This is the 2 substituted, that is alpha substitution. Plus there is also formation of 3 substituted product. See, this is the 3 substituted product. Friend, you can see here the substitution at the second position and the third position is depends on the bulkiness of this R group. If this R group is less bulky, then there is the formation of 2 substituted product is more than the 3 substituted product, and if the R is more bulkier group, then the formation of 3 substituted is the preferable, and the 3 substituted is more than the 2 substitution. We can write here one table. In that, see, this is the R and this is the ratio of 2:3. We can take here the R is equal to H, R is equal to methyl group, ethyl group. See, this is H. Then we can also take here the methyl group C2H5. Then isopropyl group CH3 twice CH, and finally the tertiary methyl group CH3 thrice C. See, the ratio of H, when we take here the ratio of 2:3, the firstly the ratio is 1:0, means that when the R is equal to H, then there will be only formation of 2 substituted product. When R is equal to methyl group, then the ratio is 100:4. It means that 100 times there is formation of 2 substitution, and only 4 times there is formation of 4 substitution. When we take here the R group is equal to ethyl group, then we can write here 90:4. Firstly, when we take the CH2, then there will be formation of 12:1. When there is a isopropyl group, then there is 19:1. When you take the isopropyl group, then there is a 19:1, and when 9.:1, and when we take here the tertiary methyl group, then there will be ratio will be 4:1. It means that as the bulkiness of this R group get increases, then the substitution at the 3 position get increases as compared to the 2 positions. So this is very important chart to understand the substitution either on 2 position or either on the 3 position. This is very important reaction in view of the competitive examination. Friend, if you understood well about the reactivity of pyrrole, pyrrole and thiophene, so mostly we can say that the 2 position substitution is major than the 3 position substitution. But in case of the pyrrole, when the bulkiness of R group which is present on the nitrogen, then bulkiness increases, the substitution at 3 position will be increases. Now let us see here, when there is substitution on the alpha position or beta position, then where is the electrophilic substitution takes place? See, this is first example in which we can say that ortho and para position at the alpha position, ortho and para dielectric group are present. If this is the substitution here, then this is ortho position, this is meta position, and this is the para position. So we can see that when there is substitution at alpha position, and substitution will be ortho and para dielectric group, that is the electron donating group, then the substitution at this position is the major and substitution at the ortho position is the minor. Now if here is the meta dielectric group, see, this is the ortho, this is meta, and this is para. If there is a meta dielectric group are present on alpha position, then electrophilic substitution takes place at the meta position. See, this is the major substitution here, this is major substitution here, this is very minor substitution, and this is very minor substitution. Now if ortho and para dielectric group are present at the beta position, then see, this is the ortho, this is the ortho, and this is the meta position, then and only here, so the substitution will be only alpha position. Substitution takes place only at the alpha position. This is the another case. If the meta substitution is present here, meta dielectric are present on the beta position, then see, this is ortho, this is ortho, and this is meta. The substitution takes place only at meta position. Only at meta position. If the meta dielectric present on the beta position here, so in a such a way we can consider which type of product, which position, which substitution takes place at which position. We can consider this type of the product by these structures. So in a such a way, the reactivity of pyrrole, pyrrole, and thiophene are takes place. In this lecture, we are discussed that how the pyrrole, pyrrole, and thiophene reacts among the electrophilic substitution reaction. If we consider about the nucleophilic substitution reaction generally does not take place on 5-membered heterocyclic compound. We have to keep one point in our mind that the nucleophilic substitution reaction generally does not take place on 5-membered heterocyclic compounds. Friend, in next lecture we are going to discuss, the synthesis of this pyrrole, pyrrole, and thiophene. Thank you.